I want to introduce to you guys Ian Feather. He works at BuzzFeed on front-end infrastructure, which includes testing, automation, performance, and resilience. And he's going to talk to us today about testing without assertions. So please welcome Ian.
Hey, everyone. Thanks for having me. I'm super thrilled to be here today to speak to you all about testing without assertions. I'm just really happy someone turned up as well. This is great. It's already off to a fantastic start. So yeah, testing without assertions is something that, like a technique we've recently started employing at BuzzFeed for testing our analytics. So I work out of the London office, and I lead the front-end infrastructure team. And so a big part of my job is figuring out the safest and most reliable way for us to get our code into production. So it's the whole deploy pipeline. Prior to BuzzFeed, I'd worked at a bunch of different places, and I've always kind of been from the front-end developer stack. So I've worked on like big static sites and single-page apps. I've written a lot of tests, and I've debugged like way more tests. But one thing I'd never done is tested analytics. Like that had never been a priority of ours until I got to BuzzFeed. And the reason that it came to us at BuzzFeed as priority was that we had a few data capture outages. So mid-2016, we had a few releases which broke analytics in certain subtle different ways. And they were fairly small and pretty contained and fixed fairly quickly. But it really drove down confidence in our developers' confidence for making changes locally without impacting, without breaking. And also the leadership's confidence for us being able to ship code in a safe and reliable manner. And it was culminated by a larger outage, which meant that we lost page view events in Safari for more than 24 hours, and it was unrecoverable data. So that was kind of the tipping point where this project was given to my team with a priority of we need to sort this out properly and make sure these tests work. So in this talk, I'm going to cover why analytics matters to BuzzFeed. I'm going to talk about the way that we used to test our analytics, and also why it's kind of hard to test analytics in a conventional sense. And then go through and detail our solution to this and how we came up with the testing without assertions approach. So why does analytics matter to BuzzFeed? This is our publishing and learning kind of cycle. Up in the top left, we have our editors, like the true creative, like geniuses at BuzzFeed who are creating content every day and publishing it out to our platforms, one of which is the website, others are the applications, and then we had distribution formats like AMP and IA. On all of those formats, some code runs which like analyzes how you use it, like whether or not you shared an article, whether or not you filtered it, and sends that back to us where we store it in databases, and then we use that to create dashboards which we can like track business value and all sorts of different bits. But the key part that's missing to this, and the part that's most important to BuzzFeed, is this part, like the learning part, this feedback cycle. BuzzFeed, we think that we've been very successful because of the way we understand our users and the way we can analyze how the content we produce connects with them. And that all happens in the CMS, like meeting these data insights with the creative powers of our editors. And so when we get situations like this, we treat this as high a priority as the site being down. Like this is very crucial for us to make sure that we are successful going forward. So I just want to take a step back and introduce a term to you that I'm going to use probably repeatedly in this talk, but which understandably means nothing to you right now. So Pixie Dust is our own analytics data pipeline. Like in its simplest form, it's a way for us to get analytics back from users' devices to our systems, but it's also the way the information flows through all of our systems at BuzzFeed, and it's sprinkled across like every single application. So yes, a page view uses Pixie Dust, but so does an edit to an article in the CMS, and so does a deploy to production. We'll trigger a Pixie Dust event. And these propagate around our environment and make it easier for us to learn from it. So why is it so difficult to test analytics? Well, let's introduce like a very straightforward test. Quizzes on BuzzFeed. I want to go and filter them. So let's say I'll use Cucumber here because it's so readable. It's not something we actually do use. But when I go to the quiz page and I click on the filter, then I see the new results. Right? This is kind of a very nice standard end-to-end test, which is testing AJAX requests. It's testing a backend service can create some new quizzes, and also that we can render them in the correct way, and the user ultimately sees what they want to see. There's an end-to-end test. It's clear. If we look at it from an analytics perspective, it's very difficult to say what the other end is. Like we're in a situation where stuff is definitely happening, right? There's JavaScript being executed, and an event is fired, and a network request is made. But from a perspective of the test, like what can I assert on to make sure that it actually has happened? So we cheated. Like historically, our approach to doing this was that I will see the event locally. And the way that we did this is we kind of hijacked the requests before they were sent off, and we popped them into session storage. So we had this abstraction over our analytics where we'd maybe flush these events, where it's sent to Pixie dust, and we would say if we're in test mode via some kind of query string or cookie or whatever, then we'll also store these events, put them in session storage, and then on the assertion side, we do browser.execute, and we return the values of session storage, and we assert them. And it looks like this. So we'd have a pull request, which would spin up the application locally and use WebDriver IO to create a session with source labs, run these tests, which would navigate to a few different pages. It would share some articles, and it would filter some stuff. And then we'd look inside session storage, assert that those values were the same as we expected in a mock, and then report on that back to the pull request. Then, if all good, we can go to master and then go to production. So, unsurprisingly, these tests were really flaky. Right? Like, we've heard a lot about flaky tests already in this conference. Like, it's going to be a common theme going forward. Flaky tests, in my experience, are a huge issue, and one that we've always tried to stamp out as soon as possible, because there's been so many instances that I've experienced in my career where people have turned off the tests altogether because of flakiness, like promising to return them back the next day, but forgetting, and leaving you in this really, really critical situation where bugs can get to production very simply, and people have no trust in their system whatsoever. Particularly, this is also a problem when you introduce tools like source labs, for example, that people start to blame source labs, or blame whatever the abstraction is, because it feels black boxy and you don't really know what's going on inside it, but you know that things are indeterministic, which kind of makes you able to get away with writing bad tests as well, because you just blame stuff. So this was no good in the current situation, and also unsurprising, because we felt like we were abusing the way that end-to-end tests should be run anyway. So flakiness is to be somewhat expected. And bugs still reached production. All these problems that happened when we had these tests running, which meant that we weren't doing effective cross-browser testing, or that they just weren't complete and they weren't testing the full range of events we wanted to test. Again, unsurprising, because people didn't enjoy adding to them. And bugs still appeared in production after deploy. So the third incident that may have finally caused us to take on this project was caused by a third-party script releasing a new version, which threw an error in Safari, because it tried to access an API which wasn't available. And ordinarily, that would be problematic, but it was worse for us because we handled that error very badly and kind of bailed out of our analytics collection in a pretty weird way, which we fixed, but ultimately the tests had all passed before this code had reached production. 2 days later, this change goes out and things break, but without us knowing it. So we set about rethinking this problem, rethinking how we can address this in a sort of non-flaky way. And that's what we started with. We wanted a non-flaky way to assert against the actual network. So right now we have a flaky system that doesn't even test the network. It just tests session storage. So we thought about ways to actually go to the network. There are like a WebDriver IO plugin, but that didn't help with the flakiness for us. And also we thought about using service workers, which is a technology that allows you to add a proxy to, like install a proxy on a website. So you're actually testing that things do leave and are making the request. But ultimately, you still have to reach into that in the same way that we were reaching into session storage. So it didn't help too much, and we didn't go too far down that route. And then we really tried just rewriting them to make them not flaky, like in the best way we could. Like went through them, spent a lot of time doing that, and got far, but we never got to that point where you could run them, hundreds and hundreds of times in a row, and they would all pass or all fail. And time was finite. We weren't going to spend forever trying to make this not flaky. And as we were going through this, like my overarching kind of theme and the thing that I was trying to go by was that tests exist to protect production. This is kind of always a thing that I've been led to believe, and I think it's a very good thing. But I could only really see this from the perspective of I need to do this on a pull request and stop something getting out into production. And that kind of led me to reach the boundaries of the skills I had and the knowledge I had to solve this problem, because we had tried so many different ways. And I was very willing to throw out the entire thing and think of another way, but I just didn't know what that was. So I had to get a different perspective. So luckily, we have a bunch of people at BuzzFeed who have like different backgrounds and have diverse skill sets. And I spoke to a colleague, Mark, whose background was working on distributed systems for a company called Halo in the UK, which is it doesn't exist anymore. It was the equivalent of Uber in the UK. And he told me about a really interesting setup they had, where they had like a real island, an island that actually exists, but they set about and they put virtual users and virtual taxis and virtual like locations in there, and then simulated regular kind of traffic patterns around the island. And then they found that if traffic fares like spiked by 300%, then they would know something was happening. This was running in production all the time. And this analogy, this idea, made me rethink like our approach to this problem. So if they can put essentially robots on an island and drive taxis around, surely we can have users clicking on quizzes and doing whatever they want in production in real time using source labs. This maybe is not like news to many of you, but like for me, this was kind of a revelation. And it was like, okay, this is a different way I can think about this problem. So apart from tests existing to protect production, like what else do tests provide us? So we think that they also exist to give us confidence. And if we can give that confidence in using a different technique, then we accomplish the same goals. So I just want to like call out these three different types of testing and how we think about them. So pre-production testing is the more conventional approach. We run this on a local or a stage version of our application, usually in a pull request and prior to it being merged into master. And these guarantee that a piece of code works at a particular time, the time that deploy was, the time the test was run. Production monitoring is real-time traffic and real-time information from instrumentation on the website that comes back to you, and you usually have to be very specific about what you want to track and what you want to monitor. But it can be very useful for capturing things like JavaScript errors or whatever. And then production testing is running the same kind of integration test that you would run pre-production, but against your production site. And this guarantees that the artifact of code works now rather than at the specific time that it went out. But it could also guarantee that it's broken now rather than the specific time it went out. If I was joining a project and we didn't have the first two, I'd be very concerned. But like the third one is a bit rarer and something that I'm starting to see more of the benefit of these days. And so yeah, given like the approach that Halo took with the the island, we thought about this last approach and how we can use some simulated production traffic to actually run these same tests. So I'm going to get into this solution that we came up with. It helps that we had our own analytics pipeline to be able to run this solution. And the actual implementation may not be super useful to everybody, but the idea of like challenging this from a different perspective, I hope is something that we can take away. So let's go back to where we were originally, this fake end-to-end test. So let's get rid of the second end, because we can all appreciate that was not the right thing to test. And let's think about what else actually happens when we make this request to load the page. So first thing that happens is a request is made from the page to Pixie API. And this request is handled by the client-side JavaScript. That is really the thing we're wanting to test. The API is responsible really just for collecting and handing off that information, and it does so to NSQ for us. NSQ is an implementation of a messaging system similar to Kafka or RabbitMQ, whatever you may use. And its responsibility is essentially to say, I have this event, who wants it? And for all those people, here you go, you can have it. And these queue readers up here, these subscribe to events about Pixie of certain topics, and one of them will have the responsibility of sticking that in a database, right? And that's really the end we want to test. Like, that's the full end-to-end system working. I didn't really want to test production database. That was kind of terrifying. But maybe instead of like testing against the database, what we could do is add our own queue reader, like another one, which listens to exactly the same events that the one that we put in the database would do. But instead of writing somewhere, it just does the assertions. And the same assertions that we did prior, again, session storage. So there are like 3 ways that this can result. It's like pass, like it matches exactly. It fails, it doesn't match the mock that we expected. Or it's a duplicate event, and we're sending too many events of the same type from the browser, which is also a bug that we have seen in the past, and which is still very problematic to deal with. We then send that to a dashboard, which for us lives on Datadog. And that dashboard looks like this. So it's not meant to be informative to the point where you can find out the problem. It's meant to be an observable matrix of our system. So we have our 3 event types that we care about: page views, page exits, and shares. And we run these in Safari and Chrome, which takes up the majority of our user base. And then we have our different pages that we run these on. And this is a great way for me to look right now at like the state of play and the state of affairs on BuzzFeed.com in terms of analytics. And it gives me the confidence that this is working right now. So if we go back to our original test, like, we no longer care about seeing the event in session storage. So this is now what our test looks like. We've removed the assertion part, which is if this was a BuzzFeed article, it would be one weird trick to get rid of flaky tests. Because there is no way this can be flaky anymore, because there's nothing to actually assert. So we removed that problem. Bulletproof. And these were previously running on a pull request, but now there's no way for us to really do that. There's no time for this to be run. So we replace that with a cron, and we run these tests continuously. So for us, this runs every 3 minutes. The other problem with this is that we have no way of feeding back to the user. So previously in a pull request, it's very clear. You get a pass or a fail, and you have to resolve that. But we're no longer stopping people to do that. So we have to be able to notify them. And for us, we use Datadog's, maybe eventually, alerting feature, and we send that data to Slack. So this will tell us if there's been duplicates or if there has been any failures, or we haven't seen any events for a certain period of time. And they look like this. They're fairly alarmist. If they happen, people usually get kind of scared. It sometimes means Source Labs has gone down. We notice that pretty fast. And then usually it's a quick check, and there's a link to status.sourcelabs.com. But it gives you kind of information that you need to go and resolve this problem. And we usually just ping the person who last deployed or last touched that code. And so this is the final system that we end up with. And the data flows around here every 3 minutes, and we assert on that every 8 minutes. So we give chance for this to happen if there are any failures. The cron we have 3 instances of in case one falls down, and we don't really care about there being too many test runs happening, because each of them are given IDs, and we use deduplication on the QR. And it has worked really, really fantastically well for us. This has been in production for a year now, and it took a long time for it to get good, but it's there. But we learned a bunch of lessons along the way. And I think some of these are hopefully very, very worth sharing. So we found bugs we didn't know about. This was because we were starting to test new parts of the system. So previously, we weren't testing the part that made the request, and we found bugs there. And we also weren't testing the routing in Pixie API, and we found bugs there. Bugs we would never have been able to actually find purely on the client side. This was actually great because we could suddenly have more observability of our systems, because there was some events that we had never been reaching our databases and which data science didn't have access to. We found that testing in production has some fun side effects. So this is the dashboard that we have at BuzzFeed. 35 delicious things to eat in San Francisco that aren't burritos. And the point of this dashboard is to show the virality of a piece of content. So this one has a virality score or social lift of 3.9x, which means for every one person who shared it, who saw it, 4 other people saw it from them. This is a really well-performing post. The post that I test against is one that I wrote, which has no content on it really, but is the most successful post on BuzzFeed.com by a mile. Because we hit it consistently, every 3 minutes it shares and we move on. We've had to eliminate this from our machine learning algorithms, from data science, and all sorts. It comes up every now and again, but it's a bit of fun. These things will happen. You have to take them into account. We learned that testing in production brought a lot of confidence. It brought confidence to leadership and to business, because they could look at any point and see that everything was working right now, not just the fact that a deploy would have happened and that deploy was fine. I know that this system is working right now and it's working correctly. And we have seen almost 0 regressions. But there's been one, but it was small and it was quickly fixed. Which is interesting to me, because we never stopped anyone deploying bugs. We removed that problem. We removed that gate to production. So it could be coincidence that is the situation that happened. But my theory on this is that actually that confidence that we gave back to developers, them knowing that we have their back, allows them to code with less fear, with more trust over the system, and to make better decisions. And I think there's a lot to be said for that, even though we don't stop you pushing those bugs to production. And then the biggest lesson for me personally has been this one. Sometimes you have to throw out everything you know about a problem in order to solve it in the way it should be solved. And for me, that was getting that different perspective from my colleague, and thinking about how other ways that we can actually solve this problem. And so I think me having access to my colleague was fantastic. Everyone in this room has access to everyone else at this conference, and sometimes you just need that one little idea which can give you a whole different perspective on how something can be done. So yeah, I would encourage you all to converse and try and find those things, and maybe something like that will happen to you, and you also have the ability to sort of see these options. But yeah, and also feel free to ask me. That's all I have. Thank you very much for listening. And we have time for questions if anyone has them. Oh, sorry, she's scared about it.
So I've always avoided testing in prod because it skews telemetry results. How would you use this approach for something where you can't have a unique flow that the user goes through that you can separate from the rest of the metrics? Like you had a particular quiz that they could go through that you could then take out of the machine learning algorithms, but if you have an application that doesn't allow that, do you have any ideas?
No, I mean, the only thing I would suggest is like having some kind of tracing on those requests that allows you to have the full like understanding of that path of information. We specifically chose to limit like the kind of blast radius of the problem for us and make it quite unique. And we could filter those events out by an ID that we pass with it. I think you could take the same approach, but if this was more like an AI rather than just controlled testing, and it was going across our entire systems, we'd have to come up with solutions like you talked about to make sure that that didn't mess up our actual data. It's not something we've come across right now, but yeah, I don't have any like, ideal answers for you.
No, it's
there,
a really great idea. It's something to think about. Thank you.
I think tracing is your friend there. Do you have a question? There's one down here.
So I just kind of wanted to ask a kind of question. So the system that you built, so the test system is kind of like another consumer of the events coming from Pixie dust, right? And then in terms of like what is actually being tested by that process, is it all the events coming from production, or is it just ones that are coming from a subset of the tests, or is it from every test? Like,
it's all of them from our tests. So that curator receives the full fire hose of analytics events from all our systems. And it looks immediately for presence of an end-to-end test ID. And everything that doesn't have one, it just discards. So then it goes from the fire hose of events to like this tiny trickle. And for each of those, it tests them against its like the schema that it has and the mocks, and then sends off the results to Datadog.
Okay, and then I think one kind of follow up to like, and you kind of mentioned this process was able to kind of catch some of the bugs within the Pixie dust thing as well, and I'm kind of wondering like because like to me it's kind of like I mentioned Pixie dust must be sending different data, like it receives one event, it may send it in different formats to different downstream consumers, and like is this process, is it like just looking at it, like I would think would be mainly able to make sure that the right thing came from the front end, but like is it also able to track the different, the different stuff going to those other downstream systems?
Yeah, so the way that, like the diagram was, I had to simplify it, but there's a chain of curators that we have, and they each do a bunch of things, and the last one sends it to a database, whatever, and we jump in just before that last one. So we've tested that full flow all the way along. And some of those have responsibilities for routing that request to different areas. And we found that some of the routing wasn't correct, which was why we realized that wasn't reaching it.
Okay.
So yeah, like had we put it immediately after Pixist API, we would have not been testing any of that. And I think that would be okay too. But luckily, we were able to put it in a bit further down the stream.
Okay, cool.
Thanks.
So I'm just interested because the testing you're describing isn't really so much testing a change in the software, but really how this whole system is working now. And that's very different. So how do you go from a failure back to the change that caused a problem? Or do you even try?
I mean, it's a great question, and that's definitely the limitation of this kind of approach, because we're testing the system as a whole rather than, as you said, like a particular code change. So when we don't really have any way of identifying a failure with the cause. So we treat this as observability of the problem, of the whole, rather than a way to actually identify it. So the only thing we do right now is that Slack message that goes back into Slack and is very noisy and says these things have happened. It's then on the teams to be aware of what has changed and to like identify the actual root cause. But we don't have yet, at least, and we're not working this actively right now, but that is one problem we haven't tried to solve. We haven't tried to tie that back to a piece of code. I'm not sure how we would do it. But yeah, it's certainly a limitation.
I just follow on. It's very interesting. You're not testing the software so much, but monitoring. I would call that monitoring.
Right.
To some extent, right?
Monitoring, but it's with a consistent stream of traffic, which I think is the difference for us, because we We couldn't test this against production traffic because our production traffic is spiky and volatile and changes with the content that we publish. So by having this consistent stream of events flowing through, it's easier for us to spot the differences.
So you mentioned you had a lot of flakiness in the tests, and you did something to remove that flakiness. Can you give us some tips to do that?
Well, I mean, my tip isn't very applicable to everyone. Like, we just removed the assertions, so there was no way for that to be like. I mean, you do that on your test, it might not be great. Oh, there's one here. And then, sorry.
So with your current design, is there anything that's a hard stop to moving this into a pre-prod production or environment?
Getting that information back to the test runner, I think. So that flow is very asynchronous right now. You can run it against stage. It does run against stage, and it runs against the QA environments, whatever. But for it to work in pre-prod and to be a blocker, the pull request or the test runner or wherever it might run would have to know when that asynchronous flow has ended and be able to bring it back to the pull request. And we currently don't have a way of knowing that. We could poll and time out, and that might work, but we make no guarantees of when those events go through, and NSQ doesn't make any guarantees about it being immediate. It just guarantees at least once delivery. So I think there could be something, but I imagine that it would be quite frustrating to developers to have to wait for that and that inconsistency of when something comes through. So it's not something we've pushed for. There's one down here.
So the data that you get, do you have a fixed environment, or you get it from different platforms, different browsers?
It's from Chrome and Safari, and it's in production, yeah.
But it's from a specific device, or it's from desktop, it's from laptop, tablets?
So at the moment, we have Safari on mobile and Chrome on desktop. And that gives us like a pretty good understanding of our user base, pretty good coverage. It's not complete. Like, we could extend this out to be using other platforms as well.
And do you see any difference between the platforms?
I mean, specifically with Source Labs, we see the fact that iOS takes a long time to load up, and that can sometimes, because this is based on a timeout system, that sometimes causes problems. The way we get around that is by just throwing more and more tests at it, because we don't care about over-testing this, and making sure that one of them gets through that in that window of time that we're asserting.
Okay, thanks.
Pleasure.